Alright. Trying to do the Advent of Code in March. Let's hopefully at this pace we get it done before Christmas. Day, not 14, day 13. Okay, so the lava's going. No, you don't see any lava. You do see a lot of ash and rock. Okay. So we have a valley, large mirrors. Most of the mirrors have been aligned. As you move through the alley of mirrors, you find valley of mirrors. You find several of them have fallen from large metal frames, keeping them in place. Okay. They're extremely flat and shiny, and many of the mirrors have lodged into ash. Okay. You note down the patterns of ash and rock that you see. Perhaps by carefully analyzing these patterns, for example this and the bottom one, you find the reflection in each pattern. You need to find a perfect reflection across a horizontal line between the two rows or across a vertical line between two columns. Great. In the first pattern, the reflection is across a vertical line between the two columns. Alright, yes. So it's kind of like a non-inclusive reflection where you don't have to go all the way, because this one includes 5. That one includes 4. Yep. In this pattern, the line of reflection, yep. Okay. So yeah, we only need to check the minimum. Same for him. So we probably go across or down and across. Okay. Alright, so we have this stuff as an example. And yeah, this one reflects there. And I guess we could have 2 functions. Or we could just, do it here. So they're already passed, so I'm gonna go, well, we need to split across new lines, right? Oh wait, is there a number actually? I think I removed new lines from the inputs. No, there's not. Yeah, I can't really remember. Import from standard, actually let's just say that's standard, and then const print equals standard.debug.print. So then we go print, yep, and then we line the slash for input line, there we go. Let's run. As for slice, yeah, there's no new lines. So what does this get input icons? I can't remember this stuff. Yeah, we tokenize. I love that. Here we tokenize on /n, but yeah, we don't. Obviously, the /n comes into it eventually, and we kind of need to separate out the /n/n. Oh, that's pretty annoying to do actually, at least here. Okay, or maybe we don't tokenize like this. Currently we just have content. Yep. Yep. Tokenize on new n. Maybe we can just Google it. Zig read file line by line store in array. Read file zig. Is there a way to do this? Maybe that's better. Yep. New split /n mem dot split. I wonder what happens if we do that. Yeah, okay, cool. That was it. We split on new n instead of tokenized, so then we have those 2 differences. line, 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 and what's going to happen is, yeah, so we can find this new line and just work backwards from there. Var start pointer, which is a u size 0. If line dot line dot length is equal to 1, then found our empty line, and we can go print, and we can have an index here, index, right, what was this, print, what am I doing wrong? Ah, a dot, yeah. Oh what? God, it's taking a while to get back into things, really. Oh, actually, is it 2 the slash n counts? I'm gonna print and length, line dot length, and length 0. 0. Oh, we're splitting on, yeah, okay. Great, 7 and 15, cool. So a minimum ratio, we can go start pointers equals index plus 1. Let's do our logic here. Found our new line, and here we can even write a function here. Single tile takes an input, constraints. Let's just say returns nothing for now. And what we could do is we'd say single tile with input from the start pointer dot dot to the end, the index. Yeah, that's it. Okay, cool. And what we're going to do is, let's just double check. Print. Cool. Can you, do you run, do you not? Oh, you need to be tried, don't you try? Great, that's really cool. Let's just do that to make sure that, you know, nothing funny is going on. New line, just in case. Cool, brilliant. That's exactly what we expect. We're gonna go across horizontal. So if we go down, we check up, right? We're just going to kind of move down through it. Okay, yeah, so we're going to be, if we start here, like as if the line is like in between the 0 and the 1, we're going to go check 1, 2. And we can break as soon as we kind of reach a max. So we're going to have a down counter starting at 0, up counters starting at 1. And what we'll do is we'll work to increase this. So we're going to go full, actually just while true, maybe. While down counter is bigger than or equal to 0, and up counter is smaller than, exclusively smaller than input dot length. Cool. And so the first time round we're only going to run once, and we're going to go if, so horizontally, yeah, they'll be the same. If standard dot mem dot equal, compared to slice and resolve, they're equal, yeah. Input at down counter, input at up counter. Actually, if not equal, break. And then here we'd go down counter minus minus, up counter plus plus. Ooh, can I not do that? I forgot that. You can't actually do that. Else we're going to continue. For OK, where equals false. I'm going to say OK equals, I should say it's true. And we break them. And we have to kind of execute this a few times, moving down counter and up counter each time. So we're going to go for 0 dot dot. This is going to go all the way to the length minus 1, I think. Input dot length, take away 1, and yeah, okay. Index, and we're going to move all of this in here. Do you just not want to index? Oh, there you go. Index. You're going to start at index, you're going to start index plus 1. What happens if I run this? Nothing much. Print at index blah. So it's going to be OK and index. False, false, 0, 1, 2, 3, 5, 5. So that first one wasn't an true at 3. If I was true at 3, next 3, so it goes 0, 1, 2, 3. Yeah, good. Okay, it's working horizontally. Then we're going to have to do this very similar thing, but vertically. So the way we do that is input 0 dot length, index, down counter goes to the left, up counter goes to the right. Input 0 dot length if. Oh, this sounds a little bit awkward, right? Because we have to count across, so we're going to have to yeah. Get slice, get grid call. I guess it's going to take an input, const U8 is going to return an array of U8. That's pretty annoying, but you know. And here, oh, we're going to need an allocator as well, because we need to allocate some slices. Allocate standard dot mem dot allocator, and you're going to need the same. Allocator equals standard dot heap dot general purpose allocator, I think. Let's try. Ziglan. I want the allocators. Allocator. Okay, so general purpose allocator does this, and you need this. So scope block. What's happening? What's going on there? Oh, we don't need to try. Does it know what you are? Yeah. There you go. Yeah. Still work? No, but why? Oh. General purpose allocator, and we go var allocator equals general purpose allocator dot allocator. Good. But not good. Oh yeah, because that doesn't really work. Okay, so we go var call equals try allocator dot alloc u8 with input 0 dot length, then for 0 dot dot actually we could probably go for input and then 0 dot dot line and an index. Actually yes, yeah, so we go call at index so yeah, that's right, call it index equals the line at, it's gonna be like, oh yeah, this has to run twice, isn't it? Yeah. Oh, sorry. No, I mean it runs once, twice. Oh yeah, no, it does. Dot input 0. Actually, we can go call now. And this gives me the call index. Then we go through this, through the input. Might not need you. And then call at call index. Oh wait, no, I'm thinking about this a bit wrong. Call index comes from above, not from here. Yeah, that's right. So call at 0 dot dot index equals line at call index. That's right. And that needs a try now. Bar call 1 equals try gets grid call allocator input, and it's going to be the down counter, the up counter call 2. And what now? Oh yeah. Call 1, call 2. Does that work? No, it doesn't, because so what I can do is I can do a defer allocator.free call 1 as soon as the scope block, which is the while loop, goes out of scope. That's alright. False, 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 and then true. Yeah, okay, I think that's working. Maybe. Might get overconfident, but you know. Right. We go, okay. If, okay, then we know this is horizontal, and we need the store the index. Index score found, use size equals 0. So every time we go around the loop, right, every time we go around the loop, we can probably check. If it's okay, then we can break, and we can do index found equals the index. That's it. And if it's okay, found, then what does it want us to do? To summarize your pattern notes, add the number of columns. Okay. Summarize your pattern notes. Add the number of columns to the left of each vertical line reflection. To that, also add 100 multiplied by the number of rows above each. So effectively, that's going to return a use size. And if it's horizontal, found. Horizontal, 100 times number of rows for each reflection. I think now we need to return. I think it's just index found. And here we go, okay equals true, because otherwise it would be false there. Index found equals 0. And then here, this returns 0 otherwise, but I'm not sure if, okay, return index found. Oh, and we need this bit of code here, right, to check if okay. Great. But if it's horizontal, how many times by 100? Index found is going to start at 0. I feel like it's going to be off by 1. Num equals, and then we go print num. Oh. Wait, no, found. At index there. So we're going to print okay and the index. Oh, wait, we have to say k equals true at the beginning. Okay. So the number of vertical lines has 5 columns to the left. Yeah, so it's off by 1. Plus 1. Okay, so we go var part 1. This says 0. Part 1 plus or equal num. Print part 1. Okay, what do we have? Many debugs statements for a 5. Okay. Let's see. Oh. Integer overflow. Down counter. Oh, yeah. Yeah. I mean, one thing I can think of is if down counter is equal to 0 was bigger than 0, then we do that. At which point if down counter is equal to 0, then we just break. No matter what happens. It's kind of an extra if inside of a loop as well. So I'm not so sure about that. Or whilst the up counter is smaller than input dot length. Huh, okay. Yeah, this one is like one that would go towards the end, right? So go away. So in the it's interesting, in the down counter, because index it's pretty. I didn't expect that. This is the line that crashes. Down counter. It gives input. Yep. You know what? Let's get rid of you. And before this, let's zero the for input line. Let's just print. Yeah, I feel like it's just like kind of off by 1 errors, isn't it? Let's check the exact one that crashed. Oh, it's literally the first one. Okay. I'm gonna comment. I feel like I'll need it later. So run. And we get an integer overflow. -76. Yep. Okay. Can I just, not? The down counter starts at the index. Could be 0. Yeah, I guess. It's basically like check once. Yeah. Alright, so keep it there. For now you work. But if I add you back, yeah. Okay, so now that bit works. Now what's the tile that's failing? There's quite a few. Ooh, it's a big one. Is it this one? Oh yeah, it is this one. Okay. $13. 1, 2, 3, 4, 5. Actually, what am I doing? 13 here, yeah. I think maybe here when I do this the up counter. Oh, this isn't the down counter actually, isn't it? Because it must go up to some amount. Up, down, up, counter, down, counter. Oh, it's straight away. So it goes up is 1, down is 0. Oh, no, it's in a loop. What am I doing? Yep, like this. Wait, what? Really? Up and then down is 0, and I go here, down, counter. What did I do wrong? So I go through the line, I go call index. Line, index. It's saying index out of 13 and 13. There, call index 13. Index 0, input 0, length. It's pretty weird. So when you go through the input, oh, wait. You should go between 0 dot. No, we should go through all the input to grab all the column. Print. So yeah, this is so obvious. I is staring at me in the face. I just know it. The input of the length is actually going to be the length of our column. 17. To go 17. And there you are. I think I found it. I was getting I was just getting the wrong thing on the alloc there. Because I was, a bit silly. Got the wrong thing. Alright, 33195. Let's go. Alright, that didn't take that long. Part 2. You resume walking through the Valley of Mirrors and smack, run directly into one. Unlucky. Hopefully nobody was watching because that must have been pretty embarrassing. Upon closer inspection, that was so unnecessary. I feel exactly one smudge. Every mirror exactly one smudge. Exactly one dot or hash should be. Well, you're up. Exactly one dot or hash should be the opposite type. In each pattern, you'll need to locate and fix the smudge that causes a different reflection line to be valid. The old reflection line won't necessarily continue being valid after the smudge is fixed. Here's the above example again. So, just for anything else, let's just paste that. The first pattern smudge is in the top left corner. If the top left hash were instead a dot, it would have a different horizontal line reflection. With the smudge in the top left corner repaired, a new horizontal line reflection between rows 3 and 4 now exists. Row 7 does not correspond reflection line, now can be ignored, but every other row matches exactly. Okay. By changing the fifth symbol on row 2 from a dot to a hash. Okay, I mean, but that can happen many times, many different ways, no? Oh, the pattern has different ways online. Okay. I'm assuming then that the puzzle input has the restriction of only having one reflection line at a time. There's a lot of processing, but there's not that many inputs, so it's probably okay. Okay. So what we have to do is basically run the exact same code, but change input. So we're going to need to kind of go through it, kind of go through the input, change row by row by row. Okay, I mean, we'll leave part 1 there. Cool, great. So we go, start point is equal to 0. Let's just do this again. And we're going to go through each one. Okay, find our empty lines. And in here, what we're going to do is we're going to change. And I'm guessing if you change a random one, there won't be a corresponding line, right? The first pattern smudges in the top left corner of the top left hash instead of dot. Yeah, so there's a lot of assumptions I need to make here, right? That the old one is still invalid. Yeah. Oh, yeah, I don't like this. I feel like I'm going to get stuck with a real input. Okay. Yeah, okay, I can see how it would be tricky, but I wonder if they have been nice to us with that input, right? Because you can have multiple input lines, multiple reflection lines, but again, there's no way for me to tell which one they want, so I'm assuming there's only one. But yeah, what if there isn't? And what if the old one is still there? If the old one is still there, but you want to find the next one, like the other reflection line, it said it won't necessarily be valid, but it could be. Oh, that sucks. It's like I have to find every reflection, like, cause there'll be 2, I suppose. Yeah, there'll have to be 2 max. But okay, you know what? Let's just write the damn code. Var save u8 equals 0. For 0 dot dot input at this between start point the index for 0 dot dot input at start point dot length I j. And here we're going to go say input at start point, input at I, and then j, save equals, or even temp is probably a better word for that. Temp is this. That's equal to if that is equal to dot, then make it equal to a hash, and temp is equal to, oh, come on, dot, that's the other way around, not dollar, just u, that's it, and then after, now we're going to do this, we're going to find u, like so. I'm actually going to say if num is equal to 0, continue the loop. Otherwise it will break to top loop. And part 2 plus or equal that. And this thing here actually goes there. I don't know about this. I don't know about this one. Cannot assign to a constant. Oh no, that's so annoying. Can I drop that? No. Oh, come on. Can I actually not? Oh. Can I do input dot pointer dot? Yeah, maybe I could do that. Pointer dot star. Is it dot star? Maybe I don't even need access and array reference. So. Can I assign to a constant? Okay. Does it have to be a constant? Like, really? Can I not change it? Do you really have to return const? Like if I do you right there. What? Expected type u8 found const. How do I zig const u8 to u8? No. Are you serious? No way, I need to like... Bro, that sucks. Like I actually have to make like a buffer and then go, do I have to do this? Oh. I think it's a skill issue, guys. I'm very sorry, but it's definitely a skill issue. Mutable slice. Is that the destination? That must be. Yeah, destination is sources line. And then expectedly make an append a mutable slice. And yup, and you can go away. got 200 part 2 too. Okay. Oh, I'm not kind of reverting back, am I? So, but after we get the number, we go. It's not pointer anymore, I need to be. Input nj is equal to temp. Because we need to keep it nice and tidy and in order. I still get 200. And this is from that. Hey, part one's wrong now. What happened now? Why is part one wrong? Part one's 200. Did I mess up? Did I mess up with not you? Oh god. Yep. No. This is exactly why I wanted to do Zig though. This type of stuff, it never really occurs. Like higher level languages, I suppose. Look, it's so perfect. What's this thing on about? And then it goes and it just borks. God damn it, man. So it's what? The 2-own slice? Oh wait, I think I have to. Oh god, I have to keep that in memory. Oh no. Yeah, you have to keep that in memory. Oh, that sucks. Is there actually no way I can just... Oh, bro. Okay, fine. Standard dots, no. Allocator dots, alloc, u8, line dot length, we copy, mutable slice, slice we append. When we do 2-owned slice, I think all the memory's freed, hopefully. I think all the memory's freed on 2-owned slice, at least that's what it says, okay. Ugh. Pain. Right. Part one's good, part 2's 700 now, doesn't look right. 400. So okay, just gonna print none. Num 300 and 400. Actually, no. Let's print that. I think I just want to skip this here. Do you compile with unreachable code? It does not, because it's great language. But okay, we'll just have to do print. There we go. That should be enough for me to see. Alright. So there we go. We changed the smudge. There. And it's equal. Has different fresh summarize zeros. Okay. Finishing goes 300. So let's try this horizontal thing goes 0. Yeah. Down count is going to start 0. It's going to start 1. Yep. If okay. Horizontal found. And then the index it was found at. Horizontal found 3. Oh, there. Doesn't found 2. Really? Here. How many times did we do that? Should do it once. Right, should go false and break. No. It should go print here. And if okay, do that index found thing. Yep. And the second one. Here. Instantly. Oh no, it's saying. We'll just get rid of that one for now. Ignore that top one. It's saying that those aren't equal. Wait, those aren't equal, actually. Oh wait, no, that's returning the right thing. Yeah, sorry. Results found 3, yeah. That's correct. The first band smudge in the top left corner. If the top left hash were instead a dot, you would have a different horizontal line of reflection. Yep. Row 7 has no corresponding reflection, it can be ignored, yep. But every other row matches exactly. Can be found fifth symbol on row 2 from dot to hash. In rows 1 2. Summarize nodes as before, but instead use the different values. Okay, I mean, okay, 300. The first pass new horizontal line has 3 rows above it, and second pass new horizontal. Is it only horizontal lines? That's pretty weird. Don't really understand what's going on here. That's right. That's one. Another pattern is a different horizontal line between row 1 and 2. Summarizing this before, but instead use the new different reflection lines. In this example, the first pattern's new horizontal line has 3 rows above, and the second pattern's new horizontal line Wait, 3 rows. Oh, wait, is this a... Wait, what? Summarizes the value for 100, I don't understand. I'm confused. 3 rows above it, and the second path is new horizontal line has 1 row above it. Sorry, what? What? Oh, okay. Summarize your notes as before. Add the number of columns to the left. Also add 100 multiplied by the number of rows of each line of reflection. Okay. Oh wait, so no, this second smudge is wrong. So that one returns 400 when it shouldn't. This one should return. Oh yeah, because 400 was the one before. Oh, I hate it. Yeah, I know, that's what, good. I'm really glad they got that in the input though. What I'm going to do is just keep track of this. I'm going to do part 1 results equals allocator.alloc. That's the tried alloc. It's going to be usize. Why not? I'll be alright. And we're going to go. Now we're going to go part 1 results at num. Could be an array list, I guess. Maybe probably not more efficient. Just make a big buffer. I think 1,000 is enough. At the index equals num. And here, what we do, or part 1 results at, or, and this is going to kind of okay, part 1 results at the wait, no. For counter, this size is 0. And we just go counter, that's what we call on here. Counter, open results counter. But there will be times when, no, maybe might be equal to num. Okay. Populate part 1. Note part 2. Print num. 400. Yeah, you're going to print 400 because that's just default, but come on, man. I'll go to sleep. Surely you're populated. You're not. Okay. Power result to index. Not index counter. Yeah, all of this, it'll be very easy to mutate memory here, but it's not. Okay, cool. I think that worked now. I'm kind of diffing between the part 1 and part 2. Okay, good. Okay, so for the example, 400, great. for the real input, processing 21450. Okay, that doesn't look wrong. Ah, but it is. 33195. Am I still getting 33195? Yeah. We still have the counter. We're still diffing. The thing I think might be happening is we're getting the same twice. So I think I can do here. Maybe var part 1 gotten just equals false. Okay, so let's lead around that, and we go if this is equal to none, then we say part 1 gotten equals true. And this has and not part 1 gotten. Continue. Yeah, because I reckon sometimes you will end up with the same thing, but let's try the example first. That's wrong now. Well, that is false. Just number 0. If you've got part 1 already. Oh. Okay, let's try again. That's good. What did we have before? We had a simpler version. Yeah, we had this. What I'm trying to solve is how many how many real lines could you get here? It's saying that I think it's single tile going for part 1 for the part 1 value. I think I might have an idea. Part 1 val usize. Okay, if they're not equal, but if they are equal, then we do index found, and index is not equal to index underscore found plus 1, and index plus 1 times 100 is not equal to part 1 val. So basically, I don't want to shove the repeat of part 1 in, and here we just dismiss that there. We have part 1 val. Okay, and then up here. I could just make you 0, right? And hopefully nothing else would happen. And in here, I could just say part 1 results at the counter. Do you work? Okay. can't remember what we had last time. 20, 22, 20, not that. I think it wasn't that. Too low. 28,996, we've tried. Okay, maybe something to do with the breaks still. It's like, okay, we go, when we break if it's not equal, we break if it's 0. And else, else is that okay to false? Yeah, I think that's right. So we don't, because we want to keep going. Oh, it shouldn't matter, right? I don't think that makes a difference actually. No, it shouldn't make a difference because it will, okay, it will just be true. The same place again. Wait, what? It does make a difference. Okay, oh, because you need to return or something. Oh wait, I don't understand why that makes a difference. Else, so at this point, okay could be true. Okay, and if okay is true, and you're about to leave, you go here. Oh, it's like up here. That's where it would make a difference. Because if you're at the very end of the loop, right, and okay is true, you'll exit here. But if you set it to false, you won't exit here. Think that might be it. Maybe. Ah, let's go. That was good. That was good reasoning for 11 p.m. brain. I'm quite happy with that. All right. Thank you so much for watching. It was a long one. I actually really enjoyed today. It was a really hard coding problem, but it wasn't like an optimization problem. It was not an algorithmic problem. It was a straight code this problem, and I really enjoy those. And kind of hard logic. Yeah. Thanks so much for watching. I'll catch you on the next one.